geometric. Do you remember from last year what's the difference between arithmetic and geometric? Arithmetic is adding, and geometric is multiplying, right? So to get from one number to the subsequent number in arithmetic, you're adding or subtracting a common difference. And then tomorrow when we get into geometric, it's when you're multiplying by a common ratio. How about the difference between a sequence versus a series? Anybody else? Sequence versus a series. Like there's an arithmetic sequence and there's an arithmetic series. No. A sequence is just a list of the terms. So an arithmetic sequence is just the list of the terms where you're adding the same number every time. Whereas an arithmetic series is when it's the sum of all of the terms. So it's like you take all of the terms from the sequence and actually add them together and you get the series, which is where that summation notation and stuff come in. So those are really the four categories. I'm trying to think. I've never done this before, but mentally you've got really, you can be arithmetic or geometric. This is me just trying to like organize. And then, so there's one category, and then whether you're a sequence or a series determines whether or not you add them all together or not. That's really the four categories of what we'll be doing. And there are definitely sequences that don't fit as being arithmetic or geometric. They have some other weird pattern going on. But the ones that we have formulas for, those are the arithmetic and the geometric ones. So the first one gives us a recursive formula where to get any term, you take the previous term and you add 2.18. So that right there tells us it's arithmetic, right? Obviously, we know everything we look at today is going to be arithmetic, but on a test, you're not going to know that. But when you see a previous term plus something, that's arithmetic. So add 2.18, add 2.18. That 2.18 would be your common difference. Models the percentage of women working in the U.S. labor force for each 5-year period starting with 1980. So in 1980, 51.5% of U.S. women were working. So your first term is 51.5%. Your second term, we're just going to add 2.18 to that. So it would be 53.68%. And your third term, add 2.18, and so on and so forth. Yes? We don't need to do that. We know how to add. Do you know how to add decimals without a calculator? Connor, you look nervous. Okay. Do you know what the next number is? Figure it out. Good job. Put you on the spot just like that. All right, so and then we do the fourth term and the fifth term. So pretty much, I mean, just conceptually, because you want to be able to wrap your head around what's actually happening here, the percentage of women working in the 80s was on a steady incline. Yes? It's probably not still steadily inclining at 2% per year because we'd be over 100 and that's impossible, but we get the idea. Okay, so general terms of an arithmetic sequence, this is the explicit formula. This is what you have to know for that. So to get to any nth term, you start with the first term, and then you add the common difference n minus 1 times. So to get to the second term, for example, you'd add the common difference just 1 time because 2 minus 1 is 1. So finding the 20th term of an arithmetic sequence whose first term is 4 and whose common difference is -7. If we're looking for the 20th term, we're looking for a sub 20. A sub 20 equals a sub 1, which they tell us our first term is 4. And n minus 1, since we're looking for the 20th term, n is 20. And the common difference is -7. Make sure you put that -7 in parentheses so you don't think it's -7. It's times a -7. So we'd have 4 plus 19 times -7. What's 19 times 7? Andrew? 130. 19 times 7? Should end in a 3, I know that. 70 plus 63. What is it, 133? Minus 133, so that would be -129. Would be the 20th term. Which makes sense. You're starting at 4, which is barely positive, and you're immediately subtracting 7. 19 times, really, before you get to your 20th term. Good? Should all be review. So here we are. Teachers in the U.S. earned an average of $30,532 in 1990. This amount has increased by approximately $1,472 per year. So because they show, and again, and I'm only speaking to this because eventually you will have a test where arithmetic and geometric are all combined on there, and really the skill is differentiating between how you know this is arithmetic and adding a common difference every time versus geometric and multiplying by something every time, right? Geometric is usually when you grow or shrink by a certain percentage, like think exponential growth and decay. Where this one, it's claiming that it was increasing by a set dollar amount every year. So 1472 was the consistent increase as opposed to a percentage increase. So write a formula for the nth term. So a sub n equals your first term. And n, and I kind of took care of this for you when I wrote this, n is the number of years after. I made it 1989. Notice I didn't make it 1990, right? Because if I made it 1990, then that would have to have been a sub 0. Does that make sense? So I made it 1989, so 1 can be a sub 1 can mean 1990. So there's our a sub 1 number. Plus n minus 1 times your common difference of 1472. And usually you're going to see that distributed out. So it has a linear look to it, which is what arithmetic growth is. So when you do this combining of like terms, your $30,532, which is your 1990 salary, and you subtract 1,472 from that, that is really putting you back a year to your y-intercept, which is year 0, which would be 1989. Does that make sense? So 30,532 minus 1472. We could try to do it in our head, but I am just going to subtract the long way. 29,060. So that number really, from a linear perspective, becomes your y-intercept, which is the starting year salary in 1989. So how much will teachers earn on average by 2020? What would we plug in for 2020? Right? We're off. We're getting back into it, Andrew. Yeah, so 31. So if you plug in a sub 31 and just do 1472 times 31 plus 29,060, you'll get your answer. Did I mention that there is a small calculator section on this one? Okay, well this test will have a small calculator section. I don't really, not that we couldn't do that multiplication out the long way. Maybe we should practice just so you remember in case you have to. But there's definitely some series stuff where the numbers become so big where I'd give you a calculator. So 1472 times 31, do you remember how to do long multiplication? 2 times 1 is 2. 1 times 7 is 7. 1 times 4 is 4. 1 times 1 is 1. So we finished our 1. We fill with a 0, and then we go through our 3. 3 times 2 is 6. 3 times 7 is 21, so we put down the 1 and carry the 2. Do you remember that? 3 times 4 is 12, plus that 2 is 14. Put down your 4, carry your 1. 3 times 1 is 3, plus 1 is 4. And then you add those together. So 2, 13, carry your 1, 4, 5, 6, 5, 45,632 it says. Good? Yeah. Well, I used this formula. So if I had used this one, I would have done 31 minus 1 would have been 30 times 1472. But I already ironed this one out and used the mx plus b version. So that's 45,632 plus 29,060. I'm just going to add that on. 2, 9, 6, 14, carry the 1, 7. So average teacher salary by 2020, $74,692. Good? Any questions? I wonder what the actual answer is for that. We're almost there. 2019. All right, so here's where we get to our series section. Find the sum of the first 100 terms of the sequence 1, 3, 5, 7. So 1 plus 3 plus 5 plus 7 plus ... What will the 100th term be? We're going to keep adding 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus, you get it. What will the 100th term be? Marissa. We're smarter than just I don't know. Let's brainstorm here. I have an idea. You have 2 minutes to figure it out. Name on this is the previous round. What will the 100th term be? What are you doing, John? Get out of here. Put that away. Take this. Put that away. Do this. Just find the 100 term. 1 is the first odd term. You want the 100th odd term. So it should be in the ballpark of 200, but how do you know if it's 199 or 201? How do you know you were lucky? Or an unlucky guess? How many of you use the formula from the front? Raise your hand high if you use that formula. Yeah, you could just use that formula. The 100th term is your first term, which is 1, plus you're adding the common difference 99 times, right? Most people did that. And I sort of, when I mentally did it in my head when I was walking around, I sort of used that logic. I didn't have the pen and paper in front of me to use the formula, but my thought was to get to the second term, I'm adding 2 once. To get to the third term, I have added 2 twice. So to get to the 100th term, I would have added 2 99 times. Does that make sense? There's always 1 less. That's really where the formula comes from. So to get to my 100th term, I added 2 99 times. If you add 2 99 times, that's 198. To 1 makes 199. So your last term, I'm going to leave some space, is 199, which this makes your second to last term easy to figure out. What's that? 197, and so on. So when you're looking for the sum of arithmetic sequences without a calculator, or even with, you don't just sit there and add them up term by term by term when there's 100 of them, right? That would take you a long time, and then if we gave you 1,000 or 10,000, we could give you enough where you'd run out of time. So the idea is, and the nice part about it is, if you add your first term and your last term, what do those add up to? 200, right? And your second term and your second to last term add up to what? 200. And they'll always, every third from the front and third from the back will add up to 200, and so on and so forth. Whatever that target number is, it will be consistent the entire time, because whatever you're adding to go this way is made up for because you're subtracting when you come back. So the grand total of 200 in this case will always be the same, right? So we have, and then you just have to figure out how many pairs there are. If there are 100 terms, how many pairs is that? 50, right? So we have 50 pairs of 200. So the grand total, 5 times 2 is 10, and add 3 zeros. 10,000 will be the grand total sum. There's a formula for it, the arithmetic series formula. That's the only formula that the Regents did not give you last year. I don't know if you remember that or not. Did you have to memorize that? Or no? Or did you just use summation notation on your calculator? Maybe you did that. But then if you had to do summation notation, you had to write your own formula. So the way I always justify the fact that the review sheet doesn't give us, or the reference sheet on the Regents doesn't give us this, is because it logically makes sense when you think about it and you kind of explore a concrete example, that the first and the last has a sum that's exactly the same as the second and the second to last, and the third and third to last, and whatever that is. That's your sum that's consistent over how many pairs, and that gives your total. So here's the formula. Series uses a capital S. So your series total through 100 terms is 100 divided by 2. That's your number of pairs. And then your first term plus your last term gives you whatever that total is. There's your 50 pairs of 200. Does that make sense? And that gives you 10,000. Okie doke. So in the next example, because we won't have a calculator on something like this, we have to plug in 1, then plug in 2, then plug in 3, then plug in 4, and add them all together, right? If we don't know any other way. But that's legitimately what this summation notation means to do. But if we just look at the first couple terms, like if you plug in a 1, you get -4. Plus you plug in a 2, you get 1. Plus you plug in a 3, you get 15 minus 9, which is 6. Plus ... plus all the way up to when you plug in a 25, you're going to get 125 minus 9, which is 116. And we essentially want to add all those up. Now, once you do that and just kind of wrap your head around what's going on, you should realize that, oh, that's an arithmetic sequence. So I don't actually need to plug in 25 numbers. I need to know what the outer total is always going to be, which is what? What's that sum going to be? 112. And how many pairs am I going to have? If you have 25 terms, well, this is also tricky. Do you realize that from 1 to 25, that's actually 25 terms? From the first term through the 25th term, you have 25 terms, right? That's usually easier to wrap your head around. What if I gave you a sigma notation from an I of 7 to an I of 20? How many terms would that be? If you plug in a 7, an 8, a 9, and all the way up to a 20, how many plugins will that be? 14. That's trickier, right? People are really tempted to just take the difference of those, but it's not, because you're plugging in 7 and 20 on both endpoints. So be careful of that. When you plug in a 1 through a 25, the difference would be 24, but don't take the difference. You're actually plugging in 25 numbers. You kind of take the difference and then you add 1 back because you count the endpoints. So in other words, back to the pair idea, n divided by 2 would be 25 divided by 2. We technically have 12 and a half pairs. We have 12 full pairs, and then we have this one stranded number sitting in the middle, which is really just going to be half of that grand total. Work it out. So that'll still work. Your number of terms divided by 2, that's technically your number of pairs, and then your first term is -4, plus your last term is 116. So that would be 12 and a half times 112. Are we going to stress out about multiplying by a decimal? We probably are, aren't we? That's how much. Raise your hand if that stresses you out. You don't have a calculator. You're immediately stressed. Okay. Here's what we're going to do. We're going to do 112 times 125, and then we're just going to, whatever that answer is, we're just going to move our decimal place over. Got it? That's one option. The other option is to do 112 just times 12, and then add on, what would you have to add on to that at the end? Because we really should have taken 112 12 and a half times. What is that? 56. So if you take 112 12 times, you'll get an answer, but we need that 112 another half of a time, which would be an additional 56. That's a second way of doing it. I mean, there's a lot. Does anybody's mind break that up mentally else in a different way? Oh, I see. Everyone see what he... So he said keep it as a fraction. So multiply the 112 by 25 first. Do that first. And then divide your answer by a 2. And that actually makes me think of another option. Divide the 2 first and just do 56 times 25. You do that. Starts to shrink up that first option, which is a 3 by 3 multiplication. But you could divide the 112 by 2 and get 56, and then just do 56 times 25. So mental math, being able to think of the most efficient way to do some of these is important. I'm going to do this one. I think that one's easiest. 6 times 5 is 30. Carry your 3. 25 plus the 3 is 28. Fill your 0. Move to your tens place. 2 times 6 is 12. Now we're carrying a 1. 2 times 5 is 10. Plus 1 is 11. $1,400. Good? All right. And then an actual predicament we might be in someday. An adult residential community offers a 6-year plan with costs each year given by this formula. Your grandmother has $400,000 in assets. Does she have enough to pay the facility over the next 6 years? Right. You think having $400,000 would be enough to take care of you until you have to pay for a nursing home. And then it's nothing. So from the conceptual perspective, the first year, or the linear approach is this has a y-intercept of $58,730 per year, plus it's increasing at a rate of $1,800 per year. So she'll pay $58-ish this year. She's going to pay about $2,000 more next year, and then $2,000 more the following year, and so on and so forth. So will that $400,000 be enough to pay the facility throughout really the next 6 years? So a couple things on a test. You have to, going back to this, make the decision. Is this arithmetic or geometric based on the way it's changing? And then is it a sequence or a series question? Are they asking you for the cost in the 6th year alone? Or are they asking you for the total cost throughout the 6 years? Which one is it? What did you say? The total, right? Because they want to know. They don't want to know if her $400,000 is going to cover the 6th year. She's got to cover the 1st, the 2nd, the 3rd, the 4th, the 5th, and the 6th year. So that's all of those yearly costs added together. The fact that we're adding them all together tells us it's a series. So if we want to find our series total, we would do S sub 6. I'm just using the formula. N is 6 divided by 2, so there's 3 pairs. And then your first term is what? We have to find that out, don't we? A sub 1 equals 1,800 times 1 plus 58,730. And then we're also going to have to find A sub 6, the last term, which will be 1,800 times 6 plus 58,730. So I'm going to cheat and use the calculator for the sake of time. 58,730 plus 1,800 makes the first term 60,530. That's how much she pays her first year. Plus, in the 6th year, 58,730 plus 1,800 times 6, that's 69,530. Three times whatever that total is, 6,530 plus 69,530, 130,060 times 3. Moment of truth. 390,000 for 6 years. Does she have enough? Yes. She's got 10,000 to spare. And then questions?